And this is the extended response questions from the Chapter 2 Linear Relations revision that's been handed out in class. The first part of this question is that the cost C of hiring diving equipment is $100 plus $25 per hour. So I need to write a rule for finding the total charge. So the total charge is going to be C is equal to, it costs you a flat rate of $100 no matter what, plus $25 per hour. So we'll call it 25T, where T is the number of hours that it's being used for. So if we're going to, I better specify T as in hours. To find the cost of hiring the equipment for 2 hours, it's simply a matter of substituting T equals 2. So C will be equal to 100 plus 25 by 2, which equals 100 plus 50, which will equal $150. Similarly, if we're going to be finding it for 2 hours and 30 minutes, that means that T will equal 2.5 hours. So we do the same thing, substitute T is equal to 2.5 into the equation. 25 times by 2.5. So wherever we see T, we replace it with 2.5. So that will be equal to $162.50. Now the next part of the question is it's asking for how many hours can the equipment be hired if we've got $375 or $400. So we need to use the same equation. C is equal to 100 plus 25T. That's just from the first part of the question. And what we do in this case here, we make C equal to 375. So in working that through, we say 375 is equal to 100 plus 25T. Take 100 from both sides, so we have 275 is equal to 25T. And then if we divide both sides by 25, we'll have T is equal to 11 hours. So the answer to this one here would be 11 hours. And if we had $400 available to us, it's the same process. So we set C equal to 400. So 400 will be equal to 100 plus 25T. Take away 100, 300 equals 25T. And then we divide both sides by 25, which will give us T equals 12. The next part of this question is asking us to sketch the graph of C against T within the domain of 0 to 6. Probably the easiest way of drawing a linear equation for something like this is to work out where your coordinates of the two endpoints of that particular sketch is going to be, or that graph is going to be. So when T is equal to 0, we already know that from the original equation. I'll just write the equation up here again. C is equal to 100 plus 25T. So that's still relevant. When T is equal to 0, then C is equal to 100 plus 25 by 0, which is just equal to 100. So that tells us starting coordinates of 0 and 100. And then go to the other end. When T is equal to 6, C will be equal to 100 plus 25 times by 6, which will be equal to 250. So that gives us our n coordinates of 6 and 250. So now to sketch the graph, our little axes like so, and it's going to be, we set up 0 and 100 there, and then we'll call this 6, and that's about 250 there approximately. We need to draw a straight line through there. Because this is less than, not less than, equal to, we can't close it, so I'll leave that open. And we'll write the coordinates for our endpoint, 6, 250. And that's the sketch of that. We'll label our axes as C in dollars and T in hours. And that will be the sketch of that. Now the last part of this question is it's saying that we have a second option being offered, which is just a flat $45 per hour. So there's no cost up front. It's just $45 per hour that you use it for. So we need to work out when is it better or when is it cheaper to use the second option compared to the first option. So the equation for the second option would be C is equal to 45T. That's the simple equation. Now we need to solve, we can solve these graphically, we can solve them simultaneously. I'm going to solve them algebraically. So first equation at the top there, this is the second equation. What I'm going to do is make equation 1 equal to equation 2. So from equation 1 we have 100 plus 25t is equal to, equation 2c is equal to 45t, so we've just made them equal to each other. So we've taken that part there and made it equal to that part there because c is equal to c. That's how we can get away with that. So now what we need to do is, looking at our equation, we'll take away 25t from both sides. That will cancel that one down. Leaves us with 100 is equal to 20t. Then we divide both sides by 20. Leaves us with t is equal to 5. Now, to have an idea of whether this is better before or after, a quick sketch of the graphs would be a good idea. So if you remember from the last part, the graph started at 100 and went through to, what was it? It was 6 and 250. The second graph is going to start at 0, and I'll just work out if t is equal to 6 for the second option. So c equals 45 times by 6 is 270. So it is going to be more expensive after 5 hours. So that's 6 and 270. And this point here, it's not quite the scale that your sketches should be a bit better, but we're going to label it after 5 hours. That's where it's more expensive to use the second option or cheaper to use the first option. So in our instance, our solution will be less than 5 hours is when the second option is better. And that's the end of that.